Hello and good day everyone. Welcome back to my YouTube channel. My name is Sir Marcy and our lesson for today is all about the quadratic inequalities. What is quadratic inequality? A quadratic inequality in one variable is an expression which can be expressed in the form ax squared plus bx plus c is greater than 0, where a, b, and c are real numbers and a must not be equal to 0, or the same quadratic expression with the inequality symbol less than or equal to, greater than or equal to, or not equal to. A solution to a quadratic inequality in X is any set of variable of X for which the inequality holds. These are the examples of quadratic inequalities. We have number 1, 3x squared plus 7x plus 2 is greater than 0. Number 2, x squared minus 16 is less than 6x. Number 3, 5r squared plus 2r plus 7 is greater than or equal to 0. And number 4, y squared plus 5y is less than or equal to 15. Before we go directly to our main lesson, let's try to study first the interval notation. The best way to define interval notation is the following table. There are 3 columns to the table. Each row contains an inequality, a graph representing the inequality, and finally the interval notation for the given inequality. Remember that a bracket means that we include the endpoints. In this case, we include a and b as part of the solutions, while a parenthesis means we don't include the endpoints, meaning to say that the solution here is or are between a and b. Now, with the first 4 inequalities in the table, the interval notation is really nothing more than the graph without the number line on it. While the final 4 inequalities, the interval notation is almost the graph, except we need to add in an appropriate infinity to make sure we get the correct portion of the number line. Also note that infinities never get a bracket, they only get a parenthesis. Alright, let's now move on to our lesson. The topic that I'm going to discuss today is all about solving quadratic inequalities. Here are the steps in solving quadratic inequalities. Number 1, write the quadratic inequality in standard form. Number 2, find the critical values. For the quadratic inequality in standard form, the critical values are the roots. Therefore, set the function equal to 0 and solve. Number 3, complete a table of signs. We must determine where each factor of the inequality is positive and negative on the number line. To the left in the negative direction of the critical value, equal to the critical value, to the right of the critical value, and write the answer or your final answer. Okay, let's try to solve problem number 1. Find the solution set of x squared plus 8x plus 15 is greater than 0. Okay, so our first step is to make sure that the given inequality is written in standard form. So number 1 example is already in standard form. Our next step is to find the roots of its corresponding equality, meaning to say we solve the roots of this quadratic inequality by making this first a quadratic equation. So from x squared plus 8x plus 15 is greater than 0, it will now become x squared plus 8x plus 15 is equal to 0. So we can solve for the roots using of the different techniques we have in our previous lesson. So in this case, I will apply factoring. So the factor of this quadratic equation is x plus 5 multiplied to x plus 3 is equal to 0. Then we apply the zero product property. We have x plus 5 is equal to 0 and x plus 3 is equal to 0. Meaning to say, we already have x is equal to negative 5 and x is equal to negative 3. This is now what we call the critical values. Okay, so the critical values in x squared plus 8x plus 15 is greater than 0 are x is equal to negative 5 and x is equal to negative 3. Our next step is to plot this in the number line. So, if we're going to plot this, we will start with the smaller value followed by the bigger value. So here, the smallest value is negative 5. So let's assume that negative 5 is here and negative 3 is here. Note that hollow circles are used in the graph to show that these two are not part of the solution set. Okay, since we're using greater than. So I will use hollow circle. Next step is we're going to test a number from each interval against the inequality. If we're going to examine this region, this is negative 6, negative 7, let's say negative 6, negative 7, negative 8, negative 9, to negative infinity. Okay? So these are numbers less than 5. So I will just write here x is less than negative 5. Also, the numbers between these critical values, we have negative 4. Okay, so this is x is greater than negative 5 but less than negative 3. Okay, on the other hand, going to this side, we have negative 2, negative 1, 0, and positive 1 to positive infinities are the numbers greater than negative 3. So I will write x is greater than negative 3. From these intervals, we're going to pick a number. Okay, so let's say or suppose I'm going to use negative 6. So x is equal to negative 6. I will use the factors, okay, of x squared plus 8x plus 15 is greater than 0. So that those are x plus 5 multiplied to x plus 3 is greater than 0. So we plug in negative 6. We have negative 6 plus 5 multiplied to negative 6 plus 3 is greater than 0. So negative 6 plus 5, we have negative 1 multiplied to negative 6 plus 3, which is negative 3, is greater than 0. Negative 1 times negative 3, that's positive 3, is greater than 0. We know that 3 is greater than 0, then this is true. Okay? Next is we're going to pick a number that's between negative 5 and negative 3. So we'll use x is equal to negative 4. Okay, so using the factors again, we have x plus 5 multiplied to x plus 3 is greater than 0. So we plug in negative 4. So we have negative 4 plus 5 multiplied to negative 4 plus 3 is greater than 0. Negative 4 plus 5, we have positive 1. Negative 4 plus 3, we have negative 1 is greater than 0. 1 times negative 1, we have negative 1 is greater than 0. We know that negative 1 is greater than 0 is not true. So that means this is false. And lastly, we're going to pick a number that is greater than negative 3. Let's say we're going to use 0. So x is equal to 0. So we plug in again this to our factors. We have x plus 5 multiplied to x plus 3 is greater than 0. So 0 plus 5 multiplied to 0 plus 3 is greater than 0. So we simplify. This is 5 multiplied to 3 is greater than 0. 5 times 3 is 15 is greater than 0. Meaning this is also true. So to find out the answer, we conclude that the inequality is true for any values of x in the interval that is greater than or that is less than -5 and x is greater than -3. So our solution set would be x such that x is less than -5 or x is greater than -3. Okay, example number 2. Find the solution set of x squared minus 2x minus 8 is greater than or equal to 0. First is we're going to find the roots of its corresponding equality. So we have x squared minus 2x minus 8 is equal to 0. So we factor this is x minus 4 multiplied to x plus 2 is equal to 0. Then we apply the zero product property. That's x minus 4 is equal to 0 and x plus 2 is equal to 0. We now have our critical values. We have x is equal to positive 4 and x is equal to negative 2. So these are the critical values. We will plot this in the numbered line. So let's assume that negative 2 is here. So we have negative 1, 0, 1, 2, 3, 4, 5. Then to the left of negative 2, we have negative 3, negative 4, and negative 5. We'll use, remember, we will use a solid circle if the given inequality symbol uses less than or equal to or greater than or equal to, meaning to say that the endpoints are included as part of the solution. In our previous example, we use a hollow circle because it uses only greater than or if the given uses less than. Okay? So here we'll use solid circle from our critical value, so we shade this with a solid circle. Next is we're going to put boundaries between them. To the left of negative 2, we have negative 3, negative 4, negative 5. We know that x is less than or equal to negative 2. Here, these are the boundaries between negative 2 and negative 4. So we have x is greater than or equal to negative 2 but less than or equal to positive 4. And lastly, to the right of positive 4, we have 5, 6 to the positive infinity. This one it goes to the negative infinity. Since this is since 5 is greater than 4, we conclude that x is greater than or equal to positive 4. Now let's try to apply or test point in our problem. We're going to test a number from each interval against the inequality. Let's say we're going to use negative 3. So x is equal to negative 3. So we will use the factor. We have x minus 4 multiplied to x plus 2 is greater than or equal to 0. So we have negative 3 minus 4 multiplied to negative 3 plus 2 is greater than or equal to 0. Negative 3 minus 4, we have negative 7 multiplied to negative 1 is greater than or equal to 7. Is greater than or equal to 0. So negative 7 times negative 1, 7 is greater than or equal to 0. And that is correct. Okay, or that is true. Next, we select between these boundaries from negative 2 to positive 4. Let's say we're going to use 0. X is equal to 0. So from our factor, 0 minus 4 multiplied to 0 plus 2 is greater than or equal to 0. 0 minus 4, we have negative 4 multiply to 0 plus 2, that's positive 2, is greater than or equal to 0. Negative 4 times 2, we have negative 8 is greater than or equal to 0. We know that negative 8 is not greater than 0, so therefore this is false. Next, we're going to use 5, number greater than or equal to 4. Let's say we're going to use 5 as our test point. So we have 5 minus 4 multiplied to 5 plus 2 is greater than or equal to 0. We have 5 minus 4 is 1, 5 plus 2 is 7, is greater than or equal to 0. 1 times 7 is 7 is greater than or equal to 0, which is also true. Okay? Therefore, by observation, we conclude that the inequality is true for any values of x in the interval, which is x is less than or equal to negative 2 or x is greater than or equal to positive 4. Okay, so these are the solution set. That's all for now. Thank you for watching and please don't forget to like and subscribe to my YouTube channel.